should be able to define a trigonometric ratio in a right angle triangle. Now, what do we use? We use this abbreviation to help us to do that. So we have sine, which is the sin. And then we say sin of any angle. So I'll just use theta for now. This is the most common one that we use. So we have the sin of theta. This is going to be defined by opposite all over the hypotenuse side, which is going to say we have op all over hypotenuse side. And then how do you define cos? C, you see C again? C represents the cosine. So we have cos, which is going to be any angle we can use theta. If we say cos theta is going to be defined as the adjacent all over the hypotenuse side. Again, it's A all over H. Yeah. So A represents adjacent. So you have the adjacent all over the hypotenuse side. So we'll say it's A all over H, basically. Yes. We're still fine. Okay? Yes. And then we have the tan. The tan is defined as the opposite all over adjacent. So you're going to say that you have the tan of theta is going to be defined as op all over adjacent. Now, this is a definition of any tan, of any cos in a right angle triangle. As long as there's a right angle triangle, that's how we define it. Now, the challenge becomes here then. You are going to have different angles situated in different places. But now, the first one that we should talk about is the hypotenuse side. That one doesn't change. Hypotenuse side is the one which is looking at the 90 degrees. Can you see the 90 degrees? If we were to put eyes here and then say this person is looking there, it's going to be always looking at the hypotenuse side. So in a triangle, how many sides do you have? You have 3 sides. Okay? So we use this one. So this one, we call it the hypotenuse side. We use the hypotenuse side. We're left with 2. This is side number 1. This is going to be side number 2. Now, side number 1 and side number 2, they can either be opposite or they can be adjacent. Now, let's define opposite. Opposite, it's me looking at you. She is adjacent to me. She's next to me. No? She is opposite to me because I'm looking at her. Does that make sense? Now, it depends on the angle. What is opposite to me and then what is opposite to you can differ. Look at me. I get it like she is adjacent to me. Again. But when you can't say I'm adjacent to you. Who's adjacent to you? It's him. Who's lying? No one is lying. Okay? It depends which you are talking according to. If you are talking according to Mr., she is the one who's adjacent. If we say according to Waitumel is not going to say this person is adjacent. Okay? What's your name? Matlam. That's not your name. That's your name. You don't know your name. Eh? Melus. Melus is going to be adjacent to Waitumel. So well, Boypil. Okay. Boypil. Here we have beta and then we have theta. So between the two of them here, it depends. They can be something which is opposite theta. So we take theta as a frame of reference. If we're looking at theta, what will theta say about this side here, which is DE? Will theta say is next to me or is opposite to me? What will theta say? DE. About this one, what is theta going to say about DE? So we'll call this person which is opposite to theta. It's not just opposite. We are being specific. Because opposite, it depends on the frame of reference. According to who? According to theta, theta will say DE is what is opposite. Now, according to theta, EF is going to be what? So he will say this is adjacent to theta. It's not adjacent. It's adjacent to what? To theta. Then another person might ask, Marase, what about this one? Because now it's next to. No, that one is hypotenuse. It can't be opposite. It can't be adjacent. That person is hypotenuse. That is why I said on the right angle triangle, it's very important for us to be able to see the hypotenuse side. And then we're going to be left with 2 sides. The 2 sides that are going to be remaining, they can either be opposite or what? Or adjacent. Because we've already used number 3, which is the hypotenuse side. But what will beta say? Let's look at beta. What will beta say? Beta is going to say something different. Beta is looking at who? Is looking at
opposite.
Is opposite to who? Yeah, so this is going to be opposite to beta. It's not opposite, it's opposite to what? To beta. This is opposite to what? To theta. So what will you say about DF? DE, man. DE
Adjacent.
is going to be adjacent to what? To
Beta.
theta.
Theta.
Adjacent. Adjacent to beta. This is adjacent to beta. Again, this one is beta.
This one is theta.
The other one is what? It's theta. Yeah, sure. Okay, now that we have this in our system, it means we can come and say, but if you are talking about theta, we are going to say opposite. This one doesn't change. This is going to be opposite all over hypotenuse. No? But the size can change depending on whether you're talking about beta or you're talking about what? About theta. Now, if we go to example number 1, we're going to start by revising what we already know. Let's start from the known. They say we should be able to calculate the length of DF, which is the side here. Which is the hypotenuse side. Okay? Now, how would you calculate the hypotenuse side? Based on what you already know from earlier grades, how would you calculate that? We're going to use theorem of Pythagoras. What does it say? It says the hypotenuse side is going to be the sum of the square of the two sides. Okay? So we're going to have r squared, which is the hypotenuse. Okay? In this case, we're going to tell them it's df all squared. This is going to be equaling to de all squared plus eff all squared. Now we know what is DE. Look here, they told us. Okay? What is DE? So tell them this is 5 all squared plus what is EF? 12 all squared. Now you want to remove this square here. How do you remove the square here? They're going to square root. Okay? So you're going to say DF all squared is going to be equaling to 169, and then you say square root, you say square root. A square root has a plus and a minus. Don't forget that. A square root has a plus and a minus. Now, what are you going to have as your answer? You're going to have DF, which is going to be plus and a minus 13. No, it's not 13, it's plus and a minus 13. Your calculator gives you one answer, but the square root always has a plus and a minus. Yes. When then you will choose the correct one. You're talking about the length of something. If it's a length cannot be negative. No? You can't be, but your height is -5. But you are so short, you are -5. So therefore, our DF is going to be what to be 13. Yeah, now I'm just going to take number B. I'm going to take number C. And then I'm going to write the sine of theta, and I'm also going to write the sine of beta. Let's try these two first, and then we'll see if time still allows us. So if I say the sine of theta, what is the sine of theta? We said we want someone who's opposite to theta. Remember, how do you define sine? It's up all over hypotenuse. Now I'm going to change it because they're talking about theta. It means I'm going to say opposite to theta, and then hypotenuse is hypotenuse. Yeah. There's no hypotenuse to theta, it's hypotenuse. Are we together then? Now, what is opposite to theta? Come and check here based on what we said here. It's DE. Yeah, I'll come and say DE then. It means I'll come and write this thing as DE all over hypotenuse side. DE. Yeah.
Without at opposite no hypotenuse happen.
You can do that. You can start by saying opposite all over hypotenuse again, and then you say DE all over DF. Now you've put the numerical values then. What are going to be the values? What is DE? We know what is DE. Right? It's far. What is DF? It's 13. Yeah? Is it 12 or 13? 13. It's 13. Okay, sure. So we're done with that one. Let's try number C. This was number B again. Let's take tan. Tan is a little bit tricky. Let's go to tan of beta. How do you define tan? You start by the definition of tan. How do you define tan? You define tan by saying its opposite all over adjacent. Now, which angle did they say we should concentrate on here? They say you should look at what? At 8. So what are we going to look for, Tina? We're going to look for opposite of beta all over adjacent of beta. Now, what is opposite of beta? You come and check here. Beta. It's EF. Yes. Huh? I took this one here. Agree, they say sine because I'm saying instead of taking sine again, it's because I've already showed you sine. Let's take another one. All over DE. Yeah? Now we know what is EF. What is EF? It's 12. All over 5. And then you are done. Huh?